All right, now we're going to put the final touches on this chapter by covering some development across the lifespan a little bit here. We'll talk about child development and across adulthood as well. And maybe we'll say a little bit more about what I said about how intelligence changes across the lifespan as we do so. We'll start with Piaget, right? So we have Piaget's famous theory, and we've talked about schemas before, so we know what those are. Piaget's claim is that what's happening here is um, when we are born, clearly he's gonna take an empiricist view, meaning we're born a blank slate, right? We don't have any innate knowledge of the how the world works around us. And so Piaget's claim is that that's our major task as an infant is we need to figure out how does this all work, right? I'm in this body, I've got arms and legs and fingers and toes and lips and a mouth and eyes and everything, and I got to figure out how do you work it all, right? How does it work? And of course, as I do this, I'm also physically interacting with my environment, and I'm encountering objects that have different kinds of properties, and I'm trying to figure out how to interact with them. Some of them are solid and I can fit them in my hand, and some of them I can't. Some of them are more liquid, like water, and when I'm in the bathtub, I can't hold it, but I can splash it and do something else. So uh, I'm learning then that there's different categories of things, right? Thinking back to the category stuff we talked about before. And I'm developing this categorical understanding as I'm physically interacting with the world, and I'm learning about how the body works as well as the world as I do all of this. And now I'm forming schemas, right? I'm forming schemas about how my body works, how to work my hands, what fingers do, what eyes do, what ears do, right? I'm also figuring out what objects are and how they work. And Piaget calls this object concepts. So this is all part of the sensory motor stage where children are using their bodies and using their senses to understand the world. And as they do this, they acquire these object concepts. One of the key themes in the object concept idea is object permanence. So we need to talk about that a little bit. But before we do, let's give a super quick rundown of the rest of the stages. So the sensory motor stage is infancy. First, taking us somewhere to the first birthday to second birthday or so. Keep in mind, there's no exact official, graduation dates for each one of these stages. They're really more better seen as gradual transitional periods. So as we transition into those early childhood or toddler years, we move into the pre-operational stage where children have now better understanding objects, so they develop mental representations of objects. We can call that symbolic thinking here. But Piaget famously notes how many logical errors children in this age range still make. One famous example of that is the conservation problem, where if you have two glasses of water that have the same dimensions and same size and they have the same amount of liquid, a child can report that they are the same. But if you take one of those glasses and you pour it into a taller, skinny glass, then the level will rise, and suddenly they'll change their answer and they will say, now there's more. So this kind of change to their answers suggests that there's something going on here, that they're very tied to the appearances of things and they're unable to understand how the quantity of volume has been conserved and all that sort of stuff. So this is a form of a lack of what he calls mental operations. And the mental operations would be this kind of manipulating of information that resides in our schema. So we could think of this as something like working memory and what we do with working memory in terms of how we manipulate and understand ideas. And kids in this age range are capable of thinking about the objects and mentally representing them, but they can't really perform these mental operations on that, right? And then we get to the concrete operational stage. So now we're kind of moving into those middle childhood, school-aged years, right? So it makes a lot of sense that kids are going to start thinking a little more logically as they move into this stage right when they start school. So they're going to have inductive reasoning. So we've covered that already. So maybe I don't need to bother defining the difference between induction and deduction, but that's what they're capable of here, right? They're starting to notice patterns in the world, and they start to try to reach for understanding uh, the explanations for those patterns. One way to think about this is to think about the kind of typical elementary school science experiment. And oftentimes, what you might do is you might grow some bean plants in maybe two or three different pots. and you're going to do something like give these different bean plants different amounts of water or different amounts of sunlight, and you're going to record their growth over the span of, let's say, a month. And then children will do this, and they record those numbers, and then you make some graphs. And what you've done is you've collected the data, right? You've and you're looking for the pattern. And then afterwards, you talk about what does the pattern mean. The opposite of that would be more deductive thinking, where before you ever conduct the experiment, you're going to focus on some high level concept like photosynthesis and get children to understand photosynthesis and then have them make predictions in advance. What would happen if we were to do this experiment where we give one plant less water than another or one plant less sunlight than another? That's part of formal operational thinking, right? So in third grade, we're not doing that kind of stuff. Instead, you just do the plant experiment and then you think about it after you've done it, after you've made these concrete observations of how these two different plants grew over a month. So that's concrete operational thinking. When we get into adolescence and into our early adulthood years, formal operational thinking now lets us to think about those abstract kind of hypothetical situations that haven't been done yet. What would happen if I did this experiment? And given my general knowledge of some complex idea like photosynthesis, can I make predictions? All right, so that's coming later. All right, now, as I said, we want to get into this whole thing with object permanence because there's some controversy here. And I think this sheds a little bit of light on helping us understand a couple of things. One is what's really going on in terms of infants, in terms of their cognitive understanding of the world, and two is a methodological challenge, which is how can we properly study it. So what we have here is the first thing I want to show you is a video that depicts a child at 7 months of age who is failing what we call the basic object permanence task. And this is a task that was invented by Piaget. And the idea here is that we're going to take a toy and we're going to hide that toy from this child, but we're not trying to be tricky, right? We're putting it under a piece of cloth right in front of the child. And what Piaget noted, as well as what we'll see in this video, is that children will consistently not search for their hidden toy. So let me click play here. Hopefully this is working. Yep. So there we see. We're going to take the toy and right under, right? So no tricks. And now our child is upset, confused that the toy is gone, but not doing anything like, let me just lift up this blanket and get the toy back, right? So what do we take from this display, from this demonstration? Well, Piaget's interpretation is that the reason the child does not search for their hidden toy is because they don't understand object permanence. And that means that when the toy is gone, hidden from their sight, I should say, from the perspective of the child, the toy doesn't even exist anymore, right? So they do not understand that objects maintain permanence even when we're not looking at them. And this fits into his schema theory. How? Because what's going on is that certainly, well, the child just had an experience here, right? Not only did the child lose their toy, but a moment later, the researcher was able to lift up the blanket and give the child the toy back. So the child might learn something from this, which was, oh, I thought the toy was gone forever, but here it is again. And maybe what happens here is that they initially start thinking things disappear forever. But then when they get things back again and again, and they see these kinds of situations where the toy must have, been there all along, they start to revise their schemas, right? And as we revise the schema, this is a process Piaget called accommodation, that we start to realize, oh, objects have their own permanent existence. It doesn't depend on whether I'm looking at them or not. And so that's when we're developing these object concepts, right? But there is a curiosity here. So let's now take a look at a 9-month-old. So now that you see this video is titled that our 9-month-old is failing something called the A not B task. And let me explain what that is later. But the first thing we're going to see is that the 9-month-old passes the regular hidden toy task, right? And so that's a milestone here for Piaget, is that somewhere around 9 to 10 months of age, children start to pass this test that we just saw the 7-month-old failing at. So let's have a look here. All right, so we saw really quick the toy was hidden under that little towel, and the child just immediately recovers it, right? Doesn't waste any time to get that back. So you're not fooling me, right? And now is holding on to it because the child is like, "You're taking my toy." Okay. And there once more time, right? Now, as the video is titled, you see this is called the A not B task. So the reason for this is that what we've just done is we've hidden the toy twice in location A. Now we're going to move it and we're going to hide it in location B. And what we're going to see is this child is going to return to location A to try to recover their hidden toy. So let's have a look. And now this child appears to be as confused as the 7-month-old. Uh, what's going on, right? Uh, we see there's also a tendency to try to go back to that initial location, right? There we go. Going back to location A. And as often the case happens, we made the baby cry. So, how do we explain the fact that this child appeared to acquire object permanence, um, and then suddenly has lost it? No, they haven't lost it, right? But we've made the situation more complex. And so what does this mean? Well, one possibility is that maybe this test is measuring something other than what we think it measures. And once again, we're back to the construct problem. So maybe what we might want to think of here is that this is a situation where we've forced this child into what we could also call a problem-solving task. And one way to approach solving the problem here is to invoke means-ends analysis, if you recall that. And so what could happen is that when there's one hiding location, the 9-month-old child is capable of engaging in means-ends analysis to know, okay, I'm in a problem space. I know my desired state, which is to get my toy back, and I have to figure out which operation to apply that will successfully get me closer to my solution state, which is lift up this little towel. Now, once we add in a second hiding location, the choice of operators becomes a little more overwhelming. It doesn't seem overwhelming to us, right? There's only 2 places to go here, but maybe from the perspective of a 9-month-old baby, it is a little overwhelming. So, what happens next? Well, I don't have a video for it, but we could imagine a video of an 11 or 12-month-old child who would not have any problems with this, right? So they would progress on and now be able to correctly move and shift their attention from location A to location B. And what we could be looking at here is the development of problem-solving abilities rather than the emergence of object permanence. And so that would suggest that, okay, the test, what's the test really measuring? Is it measuring object concepts or is it measuring something else like problem solving? So many researchers believe the latter case. And that would mean that if we're going to try to measure object permanence in children, we might need a different technique. So on the bottom, I have examples of the kinds of studies done by Renee Baillargeon, Elizabeth Spelke, and a few others also working in this area. And what we see here, let's look at the one on the left labeled tall event, short event. So superficially, each one of these events is pretty much the same thing. It's like a little stage play where some hands come out behind the curtains and picks up this checkerboard cylinder and puts it into a cup. But in one case, it's a tall cup, and the other one, it's a short cup. Now, in each case, we could ask if the child has object permanence, we want to know, do they still understand that checkerboard cylinder still exists after it's placed inside the cup? Well, one way that we can do this here, though, is that in the short version of the event, that one would be labeled essentially an impossible event, because if the cylinder still exists, and therefore it also still retains its properties, including its size, then you should not be able to place it inside that cup. But that would mean it's a magic trick. And that would mean that if it is a trick, that we should be surprised when we watch it. But we would only be surprised when watching that version of it if we understand object permanence. And so What we can see here is that children as young as 5 months of age do in fact show surprise reactions here, right? Now it's hard. So one of the things we might ask here is that when we look at the children who are 7 month olds or 5 month olds in Piaget's object search task, why don't they search for their toy? Um, Maybe it's because it requires a little more action and engagement and problem solving than they're capable of. Whereas this version of this kind of an event, the possible versus impossible event, doesn't really require any problem solving or action on perhaps on behalf of the child. They just need to observe it and recognize, hey, that's not right. That's weird. That's not expected. And they show some kind of surprise reaction, longer looking time, and some arousal response from watching the event. Something similar is on the right here. So the idea is that it's kind of hard to see, but you're looking at some kind of an event where an object kind of flips up. Imagine opening up a folder, right? Where we're going to rotate something out like this, right? We're opening this thing up. And so you got the child seated on one side watching this thing rotate out. And in one case, we have what's called the habituation event, where you just see it open all the way up and kind of move over to the other side of the table like that. In another case, though, what we're going to do is we're going to place an occluding bar on the other side. So as this thing opens up, it collides with that bar and stops right there, right? And that's the normal case, right? And the child can see that blocking bar thing. So then that's kind of a normal and expected possible version of the event to watch this thing open up and come to a stop right there at that point. In the impossible version of the event, we've made this blocking bar collapsible so that now as this thing swings open, the bar collapses and it goes all the way down. And once again, of course, you can't see it once the thing opens up, right? It's not transparent. So again, you have to have object permanence to be surprised at the impossible version. And again, this is what we find is that these much younger babies are capable of showing these surprise reactions to these events, and that would suggest they understand object permanence much younger than Piaget had suggested with his other task. Now, there's potentially a different debate here, which is that does this mean that it is something that's acquired through experience in the way Piaget described, except that it's just acquired at a much younger age? Or is it potentially just something that we are born with, right? That we just automatically understand these things. And that remains potentially a debate that I don't think we need to engage in too much. But there's another thing we want to talk about here. We can look at the ideas of Linda Smith and Esther Thielen, and where they are coming in is something called dynamical systems theory. And with dynamical systems theory, what we're looking at here is the idea that cognition is happening in this highly embodied way, and we are kind of physically interacting with the world in a way that creates what in dynamical systems is called a landscape of attractors. And so an attractor in a landscape is represented as in these three-dimensional landscape graphs on the right as a basin or a valley. And so you're supposed to imagine like a ball that's rolling down around in this landscape. And if it comes over across one of these valleys, it's going to naturally roll down into it. And it's just naturally drawn down into that valley as if it's attracted to it. That's what gravity does, right? Gravity, of course, is an attractor in gravitational space-time. So, of course, as a dynamical system, the universe also has attractors too, like in that same regard. So we're going to use the same kind of mathematical construction here to model, in this case, human behavior through a landscape of attractors, and we are drawn to certain kinds of actions in the world. And so we might say that we could potentially say that once the child learns to recover their hidden toy from a specific location, referring back to the A not B task, that location becomes an attractor to them, and they are naturally drawn back to it just because of their past history of going to that location, not necessarily because of any understanding of permanence or anything like that, or even their problem-solving ability. They're just drawn to that. And in a curious twist on this experiment, what you're looking at in this picture of the child searching the two locations is that if we do the A not B task on a 9-month-old, right? So in that previous video, we see a 9-month-old fails the A not B task, right? They go back to location A instead of searching location B. But what's happening here? So in the picture on the left, you see that the child is sitting on the parent's lap as they perform the task to location A, right? So then what we're going to do is we're going to move the toy to location B. But as we do this, we're going to have the parent lift the child up a little bit. So now we've changed their posture and they're standing on the parent's lap. So in this case, do they return to location A? Or do they shift their attention and correctly search location B? And what happens is that they correctly search location B. And so in my note here, this postural change causes them to behave like an older child, right? So that, as I said, 12-month-olds will correctly deal with the A not B task. And we can get a 9-month-old to do, or sorry, a 9-month-old to do this as well if we change their posture in the middle of the experiment, right? So once they reach to location A a couple of times while seated, we stand them up and then move it to location B, and they correctly go to location B. So this would suggest then that this change in embodiment, this change in their physical posture in relation to the target and task situation, has sort of changed the attractor a little bit, and it reduces the strength of their attractor to location A and makes them more willing to shift over to location B. So that's what we're seeing in this graph here, is that the landscape graph on the right shows how there's a strong basin of attraction at location A in the beginning of the experiment, but once we change their posture, this changes the space a little bit and also creates a basin of attraction that shifts closer to location B. And so the suggestion here is that we can explain this kind of activity without needing to invoke a lot of high-level, problem-solving ability or object concept ability here to explain how this kind of embodied history of interaction with the world is shaping the child's tendencies to do one thing versus another. It's a different level of explanation for how this kind of behavior could occur. Okay, now to wrap this one up, we want to talk about post-formal thinking. So as I had noted with Piaget, it stops at stage 4, formal operational thinking, which gets us into our adolescence and early adulthood years. And this would seem to suggest that cognitive development doesn't really extend beyond that point. And a big reason for that is, as far as Piaget is concerned, the emergence of that kind of high-level abstract deductive reasoning is the culmination of human logic, and therefore there's nothing else necessarily to be gained. Well, except for if we refer back to the issue of fluid intelligence, concrete or crystallized intelligence, or even Sternberg's contextual intelligence, and even other concepts like wisdom and judgment, one of the things that we might think here is that some of the problems, and maybe we also want to think, by the way, about some of the ill-defined problems that have a lot of uncertainty associated with them. Put that all together, and what does this mean? It means that there are sometimes problems that we have to solve in our lives. We can call them life dilemmas, if you will, that don't have clear-cut, black and white logical answers to them. So that means that no matter how much we've mastered logic, it doesn't necessarily mean we're going to be good at solving these kinds of nuanced, challenging, ill-defined life problems. But that doesn't mean that despite the despite the absence of a logical solution that we cannot solve them, but rather being able to solve it means being able to let go of some of the rigidity of logic, to be comfortable dealing with ambiguity and nuance, to understand that the world doesn't always yield black and white solutions, and that context is important. Shades of gray between black and white is also important. And this is where we might start to think, is there another kind of reasoning, and that maybe we can get better at this kind of stuff the older we get, with the more experience, the more life experience people have? Is this what we would call wisdom? Maybe, maybe not, but the idea is that what we're going to do is we're going to propose now. This is not officially part of Piaget's theory, but a much more recent idea, and we'll call it post-formal thinking, to kind of show that its relationship to Piagetian thinking here, right? Is all of the stuff that I just described would be components of this kind of thinking. I have the four features of it here, right? So again, contextual thinking, just like Sternberg's contextual intelligence, right? The ability to take the situation and the cultural context into account. The individual, even individual people's lives can be different from another, and that means how to approach a particular personal problem can depend on a lot of those kinds of factors. The dialectical thinking means integrating opposing viewpoints. So here we're talking about being able to take another person's point of view and understand uh, that kind of that dialectic, that back and forth, and maybe able to find a middle ground there. Pragmatism, right? Practical solutions, as opposed to not always necessarily picking the right solution. That's still sometimes, even if you find that there is a solution that might be logically right, some people are not happy with it. And it ends up causing more problems than it supposedly solves. So, a more pragmatic approach is to find that compromise that works for everyone when dealing with some sort of difficult conflict. And then the metacognition, we've talked about that off and on a few times, right? This maybe even relates to that intrapersonal intelligence under Gardner, of how aware you are of your own tendencies and maybe even of your own biases as well in this case. So that what that's going to tell us then is that I might be able to avoid inserting my own beliefs and my own biases. If someone asks me for advice on how to solve a problem, I could certainly try to think, well, this is how I would do it, so therefore that's what you should do, right? But what I've done is I've taken my own approaches, my own beliefs, my own biases, and I've just inserted it into this situation, and that might not be helpful. So if I can separate that, right, because I can be aware that these are my own tendencies that work for me, they're not necessarily going to work for someone else, and there's your dialectic, by the way, then I can better put myself into their shoes and maybe reason towards some sort of a pragmatic and practical solution that'll work for them. So again, we see that this kind of stuff requires a different way of approaching problem solving, right? One that's a little bit more dialectical, more pragmatic, more contextual, and less biased, perhaps, is the idea. Okay, well, there we are. We have now wrapped it up. And so, as always, let me know if you have questions.